Hey guys, okay, today we're going to be discussing flip-flops or latch circuits as they're also known. Okay, so flip-flops and latch circuits are basically the basic unit of computer memory. Okay, so whenever we're going to talk about computer memory, that means SRAMs or the primary memory as you know it of a computer is based off of the flip-flop concept. Okay, one thing to keep in mind is that unlike the previous circuits that you've encountered in logic gates, it's a type of sequential circuit, which means that the output depends on the previous state of itself. Okay, so its previous state depends is directly influencing what its output is going to be. Okay, that means it works on a pulse of inputs and not a continuous input. What this means is before, when we studied logic gates, you would always have a 0 or a 1 at the A or B terminals, right? These circuits don't work like that. You don't have a constant 0 or a 1. It's always changing, like in the real world, okay? Basically, these circuits are used to store a binary digit of data in its primary output. You'll understand all of these once we get into the actual circuitry itself. But before we dive in, make sure to refresh your memory of basic logic gates, the NOR and NAND gate especially, because the SR latch, which is the circuit that we have to study in this level, is based primarily off of these two gates. Okay, so diving right in, starting off with the NOR gate, RS latch. This is the very basic and most common flip-flop that you actually get to encounter. R and S being reset and set. These are the two primary inputs of this circuit. Okay, and Q is the primary output, and this is what we're going to be concerned with the most. Okay, basically, by default, this gate will have 0, 0 as the R and S inputs. Okay, and the output will be set at 1, and when you resolve the logic, 0, 0, this is 1, 1, 0, this is 0, right? This is the default state of the circuit, and we can send pulses or ones to each of these terminals to mess around with it and see what happens. Okay, so right now the primary output Q is set at 1, right? What if we send a pulse of 1? What if we turn the R terminal of the reset terminal to 1? Okay, what happens now is this terminal is 0, this terminal is 1. A NOR gate would output a 0, right? So now the Q output is 0. And when you resolve the logic in this gate, the Q bar output is 1. That makes sense, right? Q and Q bar should be opposites of each other. So it loops back. 1 and 1 is also the output of 0 in a NOR gate, right? So it keeps looping like this, and the output will still be 0, even if this pulse is removed, right? Resolve the logic, 0, 1, this would still be 0, right? 0, 0, this would still be 1. So this is the primary gimmick of a flip-flop. The Q, no matter what the inputs here are, the primary output Q would still hold its bit, being 0, output 0, right? Similarly, if you send one pulse to the set terminal here, okay, resolve the logic, what happens is the primary output Q gets set at 1, even if you remove this pulse, right? Take a moment if you want to resolve the logic. You will find that no matter what the inputs here are, even if the inputs here don't have a 1, the output here Q will still stay at 1. Okay, so this is how it holds a bit in memory. Okay, this is the most important concept of a flip-flop, and that's really what you have to understand to know what this circuit does. Okay, now you may be wondering what would happen if both terminals are set at 1. In reality, well, what happens is that both outputs would be set at 0, but these outputs Q and Q bar should be opposite, so technically this is an invalid state. It's kind of like it's an illegal state, and the circuit is useless at this point, so the circuit is ideally not kept in this state. Okay, bit of extra knowledge, these types of gates are called an active high gate. Okay, active high latch circuit, which is because we always send a 1 value pulse to control the output at Q, and we'll contrast with this with the NAND gate and you'll understand what this means. Okay, So diving into the NAND gate ARS latch. As you can see, a NAND gate is also structurally similar, but its function is quite different. Also notice that the outputs are changed. Okay, Q bar is now at the top and Q is at the bottom. But the biggest difference of this circuit is that by default, both their inputs are set at 1. Okay, so in contrast to the NOR gate, this type of latch circuit is called an active low because you'll be changing these inputs to 0 to mess around with the final output. Okay, so let's do that. When you turn the reset terminal from 1 to 0, what would happen? This is a NAND gate. So 0, 1 in a NAND gate would output a 1, right? So now the Q bar output is set at 1, and this logic gate would output a 0. So you've sent a pulse to the R terminal and you've successfully set the Q output to 0. So basically you've done the same thing, right? Similarly, this returns to its default state where S and R are always 1. Okay, but this output Q is not changed. It's basically the same as the NOR gate. Okay, if we turn this S terminal to 0, what happens? You've done the same thing. Okay, you've set the output Q to 1. Okay, even when this goes back to its default state of both terminals being 1. And that's basically the same as the NOR gate, just with different values and terminals, right? This also does have an illegal state where both terminals are 0, but as I've mentioned before, this is an invalid state. Okay, and basically that's all there is to a latch circuit. The differences between NOR gates and NAND gates are what you have to kind of understand, but you should be careful because sometimes in questions the R and S are switched around, right? There isn't so much of a difference between how this functions, so if you can keep that in mind, that's really all that's asked of you. Okay, basically in this level, if you can understand this function and if you can describe what happens here, okay, keep these tables in mind, and if you have an understanding of the basic gates, this shouldn't be a problem. Okay, so if you can just understand what these are used for and its basic function, that's plenty enough. Okay, to put it in the simplest terms, for a NOR gate ARS latch, whenever you send a pulse of 1 to the S terminal, it will always set the output Q to 1. Again, when you send a pulse of 1 to the R terminal, it will always set the output Q to 0, and vice versa for an AND gate. If you send a 0 to the set terminal, it will set the output Q at 1. If you send a 0 to the reset terminal of an AND gate ARS latch, it will set the output Q to 0. Okay, that's really all there is to a latch circuit. Hopefully you understood that. If you have any questions, you know what to do. Keep up the good work.